Everyone, welcome to NKZia Academy YouTube channel. I am Zia Khan from NKZia Academy. Today we are starting class 9 chapter 1st Matter in our surrounding. This is notes video. Let's start. Physical nature of matter. Firstly, talk what is matter. Anything around us which has mass and occupies space is called matter. For example, your phone, your tablet, table, book, pen, notebook, etc. are the example of matter. Matter is the five basic elements, the Panchatattva: air, earth, fire, sky, and water. These are Panchatattva. Characteristics of particles of matter. Particles of matter are made up of teeny particles. They are valent space exists in particles. For example, we dissolve salt in water. The salt, where the salt goes, it goes in the spaces between water particles and it settle down in the particles of water. Particles are in continuous motion. For example, the smoke goes in the sky. This is an example of particles of matter are continuous in motion. Particles are held together by force of attraction. States of matter. Basic basic of classification of two types based upon particles arrangement, based upon energy of particles, and based upon distance between particles. Five states of matter are they are solid, liquid, gas, plasma, and Bose-Einstein condensate. These are the five states of matter. Now, characteristics of solid, liquid, and gas. Solid have fixed shape and definite volume. For example, your pen. You compressed your pen, but it don't change its shape. It break down. Next, interparticular distance are smallest. You can see their particles are very denser. They are incompressible. We cannot compress them. We cannot apply force on them. High density and do not diffuse. Diffuse means the movement of particles with their own is called as diffusion. Interparticle force of attraction are strongest. You can see the force of attraction is very denser. Next, constituent particles are very closely packed. These particles are very closely packed. Next, characteristics of liquid. Liquid. They do not have fixed shape but they have fixed volume. For example, I say you bring one glass of water for me. The one glass is volume of liquids. Now move to next point, that is interparticle distance are larger. You can see the particle distance is larger. We can't say it larger, we can say medium. Next is almost incompressible. We cannot compress liquids. Density is lower than solid and diffuse. It can diffuse. Interparticle force of attraction are weaker than solids. You can see weaker than solid. These are the particles of solid. They are very denser, and these are particles of liquid. They can move. Interparticle force of attraction are weaker than solid. Constituent particles are less closely packed. You can see the particles are less closely packed. Now, characteristics of gas. One second. Gas have neither fixed shape nor fixed volume. You can say they have not fixed shape and fixed volume. Interparticle distance are largest. You can see in diagram the particles are very larger. They are highly compressible. The gas compress. Applying pressure and reducing temperature can liquefy the gas. For example, LPG gas cylinder at your home is liquefied petroleum gas. Next, density is less and diffuse. They can do high diffusion. Interparticle force of attraction are weakest. Constituent particles are free to move about. They can freely move. Now, plasma. Plasma are non-evolvent particles. A plasma is an inorganized gas. A plasma is very good conductor of electricity and affected by magnetic field. Plasma like gases have an identified indefinite shape and an indefinite volume. Example, lignite gas. This is diagram of plasma. Plasma gives shine to star like sun. Plasma gives shining to sun. Bose-Einstein condensate. A BEC is a state of matter that can arise at very low temperatures. The scientists who worked with the Bose-Einstein condensate received a Nobel Prize for their work in 1995. The Bose-Einstein condensate is all about molecules that are really close to each other, even closer than atoms in solid. Now, intercharge in states of matter. Matter can change its state. For example, we have water in three states: solid as ice, liquid as familiar water, and gas as water vapor. So we can conclude that matter can change its state. So let's talk about what is sublimation. The changing of solid directly into vapors on heating and vapors into solid on cooling. Example, ammonium chloride, camphor and iodine. Effect of change of temperature. The temperature effect on heating a solid varies depending on the nature of solid and the condition required in bringing the change. On increasing the temperature of solid, the kinetic energy of the particles energy which overcomes with force of attraction between the particles and there be metals and is converted into liquid, melts and it converted into liquid. The temperature at which solid melts to become liquid at atmospheric pressure is called its boiling point. You know what is boiling point of water? 100 degree Celsius is boiling point of water. The melting point of ice is 273.16 degree Kelvin. 273 degree Kelvin is equal to 0 degree Celsius. We take 273 degree in calculation. The exact value of 0 degree Celsius is equal to 273.16 degree Kelvin. The process of melting, that is changing of solid state into liquid state, is known as fusion. Effect of change in pressure. Increasing or decreasing the pressure can change the state of matter. Applying pressure and reducing temperature can liquefy gases. I give you an example of LPG and CNG. CNG gas, which used as petroleum gas in our vehicles like rickshaws, etc. Solid carbon dioxide is stored under high pressure. Solid carbon dioxide get converted directly to gaseous state on decreasing pressure to 1 atmospheric without coming into liquid state. This is reason that solid carbon dioxide is also known as dry ice. What is latent heat? Latent heat, the hidden heat which break the force of attraction between the molecules during change of a state. For example, take a beaker take in 100 ml of water in it and give heat to it. You can see you give heat and the temperature not going above the 100 degrees Celsius. Why this happening? Heat is continuously giving. You give heat is continuously to the beaker, but the temperature don't increases. What is the reasons of don't increase in temperature? The reasons is the, the molecules in the beaker absorb heat to break the force of attraction between them. Thank you for this session. In next video, we cover all this chapter. Subscribe our channel NKZIA Academy for more videos of NEET, Class 9th, MPSC, UPSC, etc. Thank you.